Hello and welcome. In this video, we will be going over a guide on how to calibrate your Scramble Champions kit to help you better perform at your next competition. So the first thing that we are going to do is that we are going to increase the traction of our vehicle's wheels. And the reason that we're doing this is because sometimes when you're testing your vehicle and you're using a significant amount of power, the wheels of your vehicle may sometimes slip or your vehicle may sometimes skid. And again, by increasing the traction of your wheels, you can actually prevent your vehicle from slipping and skidding. Alright, so the first thing that you're going to do is you're going to get the wheels. They don't have to be detached, you can do it while it's attached. You're going to need the 4 balloons and you're going to need some scissors. And essentially what we are going to do is we are going to cut out a section of the balloon, one for each wheel we want to put the balloon on. And then we're just going to, just like with the wheel treads, we're just going to put the little sliver of balloon we cut out on top of that. So what I'm doing is I'm folding this balloon in half and I'm just going to cut off the ends of the balloon with some scissors, like so. So one end of the balloon off, and then I'm going to cut the other end off. And after you get everything cut, you should get a little ring of balloon. It should be fully attached. There should be, and then after you get that done, you just have to, just like with the wheel treads again, you just have to stretch that balloon over the outer edge of your wheel. So now what we are going to do is we are going to make a dial for our wheels. And what this dial is going to do is it's going to allow us to more effectively, precisely, and consistently count the amount of rotations we're putting on our brake axle. And if you remember correctly, we are using a wing nut braking mechanism. So you only need to put a dial on one of your wheels that are on the wing nut brake axle. Also, the dial that we will be using can be found in the link in the description below. All you simply have to do is print out the dowel from any printer. It doesn't have to be any special type of paper, just any type of paper will do. Alternatively, if you do not have a printer, you can just simply draw the circle by hand. And this circle for the dial that we're using is a circle that's just divided into 24 even parts. And the reason that it is divided into 24 parts is that the diameter of the circle is roughly 20 centimeters. So every increment of the dial should be just about 1 centimeter. So again, if you rotate your axle about 1/24 of a rotation, then that should mean that your vehicle would move 1 centimeter forward. So to make the dial, what you're going to need is you're going to need some scissors. You're also going to need the piece of paper with the dial on it, or you could have a hand-drawn one. And you're also going to need a wheel. And again, the wheel does not have to be detached. If it is attached, then all you need is need to find the inside diameter of your wheel. And again, if your wheel is detached, all you have to do is place your wheel over it, draw a circle around your wheel, and if you don't have it, all you have to do is find the diameter of your wheel, which should be either 70 if you're making a dial for the big wheel, or 60 millimeters if you're using it for the smaller wheel. And all you have to do is mark 60 or 70 millimeters onto that dial on each of the 24 spokes like so. So I'm taking a ruler and marking that, and if you do not have your wheel, if your wheel is detached, then again all you have to do is place your wheel over the center of the dial and then draw a circle around it. After you do that, what we are going to do is we're going to place a number on each of the lines of the dial from 0 to 23. Right, so 0 will indicate that you've made a full rotation, and each of the other numbers will indicate a number out of 24. So for example, if you had the wheel and the top number, let's say your wheel was set at 24, or excuse me, 23, right? So that would mean you've made 23 out of 24th of a rotation. So again, I'm just placing a number on each of the dial lines, and I'm marking it from 0 to 23. At this point, you can either laminate your page, or if you do not have a laminating machine, all you need to do is get some clear masking tape, or excuse me, not clear masking, clear packing tape, or clear scotch tape. And what we're going to do is we're just going to layer a bunch of that tape on top of our dial. And what this is going to do is it's going to allow our dial to become more sturdy, and then allow us to securely attach this dial to our wheel without the paper sort of crumbling or becoming soaked or anything like that. And after we get all of that tape on there, what we're going to do is we're going to cut out the wheel dial, and then we're also going to use a razor blade, X-Acto knife, anything really, and then we're going to cut out a roughly between a 1/4 inch and an 1/8 of an inch, large hole in the center, and that's going to allow our wheel to fit onto our, allow the dial to fit onto our wheel. After you get that wheel dial cut, all you want to do is just glue that wheel dial to your wheel, and you can use super glue or any other type of adhesive. And with that, you should be able to properly and accurately measure how far your vehicle is going to go, adjust your braking mechanism, so on and so forth. So I wanted to briefly discuss the way the wing nut braking mechanism works before continuing, and just to clarify, the way this braking mechanism works is that as your vehicle travels forward, the flat portion of the wing nut moves closer and closer towards the spring, and it will eventually compress that spring. And when it does, your vehicle will slow down and eventually stop. So the way we're using a dial in this braking mechanism is that it's going to allow us to be more precise when we're counting the amount of rotations we're putting onto this wing nut for our braking setting. So what we first want to do when we're calibrating this is we're going to move this wing nut all the way back furthest to the left, so all the way back to those 2 hex nuts, and then we're going to put roughly 10 to 20 forward rotations onto onto our brake axle, and then we'll test it from there and see how far it goes. So if we test it and our vehicle happens to travel 10 meters, then we know if we do a full rotation or 2 full rotations, then extra forward rotations, then our vehicle will travel 24 or 48 centimeters less. So you can kind of use each increment on your dial to adjust the distance your vehicle travels by roughly a centimeter. And I also wanted to briefly talk about how you can adjust the weight of the weight that you're using for your launcher. And if you followed our launcher video, you should have a weight block that looks something like this. And all you really have to do is just cut up a bunch of these adhesive tire wheel weights. And after you do so, you just have to stick them into those little grooves of the aluminum angle beams. And the good thing about using some of these self-adhesive wheeled weights is that if you run out of space inside the grooves of your weight block, all you have to do is just stick them either on top of everything or to the side, because they are self-adhesive. So I also wanted to briefly discuss how the launcher works. So the first thing you want to do when you're setting up your vehicle to launch is you want to push that vehicle all the way back as far as you can. And then what we're going to do is we're going to take a loop of string and we're going to loop that loop of string onto this screw that is to the left of the launcher. In the video it looks like it's to the right. And then we're going to loop that string onto that back pin of the vehicle, and then we're going to hook that loop onto the other pin that is adjacent to the screw. And what's going to happen is when the weight falls, right? So when the weight falls, it's going to pull this elastic, and this loop of string that we have here is going to hold your vehicle in place until that your weight block actually falls all the way down and hits that lever. So this will allow you to generate the maximum amount of power possible before your vehicle launches, and that will help you get the fastest times. So after you get your vehicle hooked in, what you want to do is just loop that string that's connected to your weight block over the back pin. And what you want to do is you want to pull on the string to see if your back of your vehicle is lifting. And if it is, then you might want to adjust the position of your eye hooks. And if you lower the position of your eye hooks, then your vehicle is probably not going to lift up anymore. So that's for some quick clarification. The reason your vehicle is moving upwards is because when your string is being pulled, it's being pulled upwards. So what you want to do again is just lower the position of your eye hooks, so that your vehicle is not being pulled upward when the string is being pulled. So for the purposes of this demonstration, I'm just going to use my hand instead of letting it fall by itself. But if you launch your vehicle, it should look something like this. So if the weight block falls down, then I'm holding it in place as well, but then the elastic, the latex tubing should extend a whole lot, and then by the time your weight block falls all the way down, your vehicle should launch. And if your weight block does not fall all the way down, it means either you're using too little elastic or latex tubing, or there is not enough weight on your weight block. If you don't correct for your eye hooks when you launch your vehicle, you'll see it's going to jump upwards, and then you may encounter issues like that. So again, this is another reason why you want to correct for those eye hooks. So if you're noticing that your vehicle isn't moving straight when it's being launched, then you might want to consider adding a track to your vehicle. And what we're going to do is we're going to take some thin strips of wood or any other material. Here I'm using 1/16 inch thick wood strips, and I'm just going to either glue them down, or if you're using a thicker piece of wood and a more tougher piece of wood, then you could consider screwing them down. And then what we're going to do is we're going to make a guide on our vehicle, and this track is going to allow our vehicle to, or is going to make sure our vehicle moves in a straight line as it's being launched from our launcher. And again, that's going to help us with consistency. It's going to help us make sure our runs are as straight as possible, and so much more. So again, what I'm doing here is I'm just taking some super glue and I'm just going to glue these wood strips onto the track, and I'm going to space them out roughly a 1/16 of an inch. You can do a little bit more, but I'm just going to place them on my base here with some super glue, and then space them out just a little bit. The thickness you want to space them out should be not a whole lot, but it should be enough to allow a credit card to slide through. And after you finish up setting up the track, what you want to do is just take a couple of the blank key cards that are included in the kit, and what we're going to do is we are going to attach these key cards to one side of the carbon fiber script. It doesn't matter which side you choose, we want to make sure they're all collinear so that your vehicle slides properly. So what we're going to do is we're going to measure the height at the base of our launcher, and if you are using the exact same dimensions as our kit, our plans, then it should be 1/2 inch. So we're just going to place our blank key cards on our vehicle and make sure they're at least 1/2 inch above the ground and just slightly above 1/2 inch. And then we're just going to mark that there, cut them out, and then glue them to the inside of our chassis. And then we're going to repeat this process with the other 3 key cards. We're going to space them out a little bit, and this should allow us to have a proper guide for our vehicle when we launch it. So now what we are going to do is we are going to make an aiming mechanism for our vehicle, and this is going to allow us to become more consistent and precise while we are testing our vehicles, whether it be at practice or at a competition. So what we are going to do is we are going to find 2 large paper clips, and we're going to open them up until we get a relatively straight and 90-degree L shape. And then we're going to glue 1 paper clip to our front axle 3D printed piece and 1 paper clip to our back axle 3D printed piece. And we want these 2 paper clips, the extended portion of the L, to be facing upwards and to be somewhat collinear. It doesn't have to be perfect, but the more perfect it is, the easier it may be. So after we get the 2 paper clips glued on and secured, we can use super glue, you can use tape if you want also, but after you get that attached, your vehicle should look something like this. And the 2 paper clips should, the paper clip in the front of your axle should not be behind your backstop. If it is behind your backstop, then you probably will not be able to see, not be able to aim your vehicle at all. So you want to make sure that the backstop is not obstructing any of the paper clips. Now what you also will need to make is an aiming block, and here is an example. I just used a piece of foam board and then some scrap piece of foam. You can also use cardboard, some scrap material, literally anything. And what I did is I drew a line that is perpendicular to the ground, and I put a couple pieces of colored tape, so that if I'm trying to aim my vehicle to, again, 11 meters, it might be very difficult for me to see this thin black line. So I just have these colored pieces of tape to help me see. And I also have a left and right on my aiming block. So for example, if I'm testing my vehicle, and in my practice log I say I set my aiming block at 10 centimeters to the right. So I would make sure I have an L and an R so I know which direction is right to reduce any confusion. So again, so that would be 10 centimeters to the right, this may be 10 centimeters to the left. So I just put that there just so there's no confusion during the competition. So now what we are going to do is we are going to we're going to adjust the steering of our vehicle. And here in this picture, in this demonstration, we are using a wheeled champions kit, but the concept is exactly the same. So what we want to do is we want to align our vehicle in a way that we can tell whether this vehicle is going to move in a straight line or if it's veering to the right or left. So what we're just going to do is we're just going to roll the vehicle onto the track, and depending on whether this vehicle veers right or left, we can adjust the steering with the two bolts in the very front of the vehicle. And this is just going to be a demonstration on a vehicle that is not moving straight, is veering towards the right in this circumstance. So here I launch it, and as you can see, it's moving heavily towards the right. So if you adjust the steering, you can fix your vehicle steering and make it move more straight. So as you can see, our vehicle, after testing it, moved to the right. So what we're going to do is we're going to pivot our front axle to the left. And to do so, what we're going to do is we're just going to loosen the adjustment arm bolt and the front pivot bolt. And again, this is a wheeled champions kit, but the process is exactly the same. There's a front pivot bolt and an adjustment arm bolt, and we're just going to pivot our axle towards the left so it accounts for our vehicle that was turning to the right. If your vehicle is turning to the right, you want to pivot it to the left. You can just continually do this process until you get a vehicle that doesn't veer significantly. It's okay if it veers a little bit, you can always accommodate that with the aiming, but if it moves straight, then you should be able to see it. Here, the wheeled car is moving relatively straight, not perfectly straight, but it's something that we can account for with aiming. So again, it's moving straight like so. To calibrate the aiming of your vehicle, what you're going to want to do is just place your aiming block at the center, the target point of each of one of the target distances, and you're going to repeat this process for each target distance. And then what we're going to do is we're going to set up our vehicle for testing, and then we're going to align these two paper clips with that center line of the target point. So if you aim it properly, it should look something like this. So after testing our vehicle, this is a wheeled car, but the process is the same. So if we test our vehicle and it's the perfect distance, but it's moving to the right, it's not dead center with the target barrier, what you want to do is you want to measure that vehicle's distance to the right or left of that target point. In this case, let's say it's 10 centimeters away, and we aimed that aiming block dead center. So the aiming block was right there. What you want to do is, if your vehicle traveled to the right, you want to add that distance to the left. So our vehicle traveled 10 centimeters to the right. The next time we aim it, we're going to put the aiming block 10 centimeters to the left, and that should account for the variance in left or right.